the next question, number 25. For the signal flow graph shown in the figure, which one of the following expressions is equal to the transfer function y of s by x2 of s at x1 of s is equal to 0? So we have been given our signal flow graph along with 4 options to choose from. So if you observe the graph given to us, we see that there is one forward path alone, and we have 2 loops and 2 inputs, x1 of s and x2 of s. Now in order to solve this, we will have to use Mason's gain formula. And Mason's gain formula gives us the transfer function as 1 by delta sigma k delta k pk. Now let's expand what delta and delta k is. So first delta. Now delta is written as 1 minus of the sum of gains of all single loops plus the sum of gains of all 2 non-touching loops. Now in this expression, we see that sum of gains of all single loops. We have single loops here. We have 2 loops. But 2 non-touching loops. We don't have a pair of non-touching loops over here because the 2 individual loops that we have here in this graph are overlapping each other. They are touching each other. So this expression, this part of the formula becomes 0. Though we do have sum of gains of all single loops, we will come to that part. Then we have delta k. Now delta k corresponds to the forward path, the gains of the forward path. But this is the sum of gain loops not touching the forward path. Not touching the forward path. We have 2 loops and both the loops are touching the forward path. So that means delta k in this problem is equal to 1. Since we don't have non-touching loops that do not touch the forward path, then there's no gain for delta k at all. It's just 1. And pk is the forward path, the number of forward paths. Now let's solve this step by step. We'll start with the forward path. That's our first step. I'll draw the figure here so that we don't have to turn back all the time and refer. We have our output y of s, 1, g1, g2, input x2, input x1, and we have a feedback here which is -1 and another here which is -1. Okay, so we start with the forward path. That's our first step. We have exactly 1 forward path. So we're going to call that P1. And to find the gain, we just have to multiply the gains of each portion of the forward path. 1 into G1 into G2, which gives us G1, G2. The next step is to find the individual loop gains. Individual loop gains. We'll call them P11 and P21 because we have 2 loops here. We'll call this P11 and we'll call this P21. Now, the loop gain for P11 is again the multiplication of the gains and the feedback value given. So that's 1 into G1 into -1, which is minus G1. Similarly, for the second individual loop gain, P21, we multiply the gains G1, G2 along with the feedback value. So that's G1 into G2 into minus 1, which is minus G1, G2. So we have our forward path, we have our individual loop gains. The next step is to find out what the transfer function is. We can substitute all that we have already and put it into the transfer function. So the transfer function we saw earlier is 1 by delta into, now since we have just one forward path, we would have delta 1 P1 as the numerator. Here k is equal to 1. Now delta 1, the value is 1 since we don't have loops that are not touching the forward path. And delta, if we expand that, we get 1 minus P11 plus P21. Now let's substitute the values. Okay, here the transfer function is the output by input. Now in this, the first thing we are doing is writing it in terms of y of s divided by x1 of s. I'll show you how we can change that to x2 of s once we have gotten the expression for transfer function. So delta 1 is 1, P1 is G1, G2, P11 and P21 are the values here. Let's substitute all of them. We will obtain G1, G2 divided by 1 minus G1 minus G1, G2. We can solve that further and write it as G1, G2 divided by 1 plus G1 into 1 plus G2. Now, the question asks us for y of s divided by x2 of s. Now, x2 of s comes at this point here, which means our forward path is now this portion. The portion that is ahead of x2 is ignored, which now gives us G1 is ignored and we get G2 divided by 1 plus G1 into 1 plus G2. Now this is our expression for the transfer function asked in the question. G2 divided by 1 plus G1 into 1 plus G2. And this matches option B. Well, this is the entire solution and I hope this has helped.